an integrated design of world in miniature navigation in virtual reality. So yeah, got a video for that, and hopefully we can have somebody that can take some questions at the end of it. Okay.
Hi, my name is Samuel Truman. I'm a master's student and also part of the Games Engineering Research Group at the University of Würzburg in Germany. And today I'm going to talk about navigation in VR. Navigation is one of the most important questions regarding VR. And it does not only mean locomotion, but there are also some cognitive aspects involved in navigation. There are different navigation phases. First of all, the user has to get an idea where he is relative to the rest of the environment. He then has to plan ahead what he needs to do in order to get to his desired location. Then he actually has to move. And finally, once he reached his desired location, he needs to know where he is relative to where he come from. There are different navigation methods in virtual reality, as you all are aware. For example, there's wheel walking, which means that the user's actual movements are one-to-one mapped into virtual reality. This has a lot of advantages. So, for example, it has a very low risk of inducing cyber sickness, and it is also, of course, very intuitive, because this is how we are usually moving anyway. However, there are some disadvantages. So, for example, it is relatively slow, and also it is quite exhausting, for example, if the user has to cover a huge distance. There are, of course, many other navigation techniques, for example, teleportation, which is also very popular. And teleportation is a great example why the last phase, the reorientation phase, is so important, because in teleportation often the user is losing his orientation because he is teleported somewhere and then he has no idea where he is relative to where he's coming from. Most VR navigation techniques only allow the user to move to a location which is in line of sight, but there are some methods which allow the user to move anywhere. The world in miniature navigation technique is one of these methods. The general concept is quite easy. Basically, there's a copy of the entire virtual environment, and this copy is scaled down. In its original form, this scaled down miniature of the virtual environment is attached to the user's hand, and there's also a representation of the user in the miniature model, which indicates where the user is in the virtual environment and also how he is oriented, so where he's looking at. The user can also apply changes to the representation of himself in the miniature model, and these changes will be also made to his actual position in the level. So if he moves his representation somewhere, he will be moved to that position. There are some extensions to this basic concept. For example, it lacked scalability, so that's why there are extensions which allow the user to scale the miniature model up or down, and also display only part of the virtual environment in the miniature model. And the user can modify which part is displayed. Also, the original concept had some issues with occlusion. So, for example, if there are a lot of buildings or multiple story buildings and there are walls or furniture, and they are all blocking the user's view. So the user cannot choose every destination. That's why there are occlusion handling strategies, and there are also some other extensions to this concept. The notes that are underlined are things that we did not previously found in any literature, and these are things we added. So our general goal with this concept was to integrate all these different extensions to the virtual miniature navigation technique and integrate them into one toolkit. And we also found some missing features or opportunities to improve the concept, and we also implemented those features. So let's have a look at how this is looking like. We've implemented all these features using the Oculus Quest, and we also used the corresponding Oculus Touch controllers to support gestures. There are different techniques to select a destination, which we will have a look at in a minute. And we used Unity to implement all these features. We also implemented the features that related work already implemented, but we always try to improve the usability. And we also focus a lot on user guidance, so we try to give the user some visual aids at any given step in the navigation process. Okay, so instead of attaching the miniature model to the user's hand, we decided to treat the miniature model as another 3D object in the virtual environment, which means the user can grab it, carry it around, or leave it anywhere in the scene. He can grab it from the distance, and if it's not within line of sight, the user can press a button, and then a new miniature model will be instantiated in front of him. We visualize this process by dissolving the old miniature model, and at the same time we are resolving the new miniature model in front of the user. To select the destination, we implemented two different methods. The first one is direct selection, which allows the user to point at a destination in the miniature model, press a button to select this destination, and then use the thumbstick to rotate and choose a rotation at this destination. The user can then press a button to confirm, or he can choose another destination. Then there's the pickup destination selection method. This time the user can pinch his index finger and thumb to pick up his representation or the representation of himself and place this anywhere he wants to be, and then he can confirm by double tapping, and then he will be moved to this new destination. We found the pickup selection more intuitive because it is also matching the overall gesture approach that we used, gesture-based approach that we used. Regarding scalability, we've implemented a scaling feature. We used gestures to allow the user to scale the miniature model up or down, so the user has to grab it with both hands and then widen or narrow his hands. To scroll, we support two different modes. The first one is the automatic mode, which automatically centers the player at all times. The other one is the manual mode, which allows the user to use a thumbstick and then scroll through the visual part of the miniature model. To deal with occlusion, we support three different methods, and all of these methods can be combined with each other. The first method is drawing the miniature model semi-transparently. This is of course very easy, but we found it very useful, especially for small environments. Then there is something we call colored view. This is similar to a pre-existing feature, but instead of using backface culling to hide the entire wall, we hide everything that is within a cone-shaped area, which is dependent on the user's view direction. This also allows the user to change the distance between himself and the miniature model, and that way he can look through multiple walls behind each other. There's also a technique we call melting walls, which is a similar principle, but this time everything is hidden within proximity around the user's hand and arm. This allows the user to grab and reach within or inside buildings, and then he can also select destinations in buildings. As I already mentioned, we try to improve the user's guidance at every phase of the navigation process. So once the user selected a destination, before the travel phase takes place, we display a travel preview animation, which visualizes the travel phase. We also show a preview screen, which shows the selected destination in real time. There are again two modes. The automatic mode automatically opens the preview screen every time a destination is selected. And the preview screen is always placed above the miniature model. The pickup mode allows the user to use the same pinch gesture to grab the preview screen and place it anywhere he wants it to be. And after the travel phase took place, we show a path trace for a few seconds to give the user some sort of idea where he is relative to where he's coming from. And this path trace is displayed in the miniature model. So to sum things up, we've implemented a virtual miniature navigation technique, integrating all the different extensions we could find. And also we've implemented a few new features to improve user interactions, occlusion handling, and also user guidance. This virtual miniature navigation toolkit will become available in the Unity Asset Store. And once the Asset Store page is online, you can find it under this URL. We also plan to conduct a user study to evaluate the usability of our new features. Thanks for your attention.
Great. If anybody has any questions to raise, if Samuel's around.
Yeah, I'm here.
Anybody around to ask a question, or if you want to pop it in the chat as well, then we can answer that, or it can be taken over to Discord. No? Anybody want to raise a question? I have a quick question. A lot of VR games are based on sort of a static player. Do you think the way in which you've introduced the movement would change that kind of incorporation, or do you think it'd just be very similar to the current games in terms of their move to more of a movement base?
I think this new kind of navigation technique has great potential to change drastically the games in VR. Especially serious games, for example, they could benefit from a move of the user changing his position very quickly. So he has an overview of the entire environment and he can look at it from different perspectives. So yeah, I do think that it will make a difference.
Fantastic. Well, if there is any other questions and you just want to drop them into the chat or onto the Discord, I'm sure they'll be answered by Samuel. Okay, up next, because we have to sort of move along relatively quickly. I think Daniel, you can go now.
Yep, all set.
Fantastic. Okay, so if you want to share your screen, I think you're doing it that way, aren't you?
Yep.
Okay.
Can you see the slides okay?
Yep, that's fine.
Great. So Greetings from Hong Kong, and thanks for having me at FDG. Apologies for somehow ending up in the wrong room at the time of my talk. But today I'll be giving a very brief overview of some of the ideas behind Dialogic, which is a toolkit for writers to use in scripting interactive dialogue with generative elements for games and other interactive experiences. And Dialogic consists of three parts: the scripting language called Dial, the interpreter and runtime libraries for various platforms, and what I call the workbench, which you can see here. And this is a browser-based environment for visualizing the dialogue flow, for editing, validating, and testing dial scripts, complete with syntax highlighting and linting. Thus far, Dialogic has been used on two award-winning projects, Tendar by Tender Claws, makers of virtual reality, The Underpresents, and some other very cool titles. And they pitched it as the first long-form interactive storytelling game in augmented reality. And then Inspector, which is an interactive installation exploring algorithmic manipulation and hyper-personalization via the psychometric profiling of visitors to the installation. And these titles, Tendar especially, are what I call vast writing surfaces. And to give a sense, reading the dialogue for an average reader from start to finish would take nearly a month to complete. And these types of spaces present real challenges for dialogue creation. They require a huge amount of content that is difficult, time-consuming, and expensive to source. And I won't read through these quotations due to time constraints, but many of these challenges have been previously noted by researchers, here by Matthias in 2007, here by Ryan et al. In 2015. And as they've noted, we can try to use generative processes to ease this authorial burden, but we don't want to limit our projects to only writers who can code, as this is still a very small fraction of the pool. So how can we support the full range of writers, from totally analog to procedurally fluent, even as over the course of a project, these fluencies are likely to change? Because the writing process is iterative, the textual content for a game is often also changing. So how can we decouple it from the game programming so that each can continue at its own pace, but still integrate as necessary? And finally, how efficiently to find the best fragments of dialogue at runtime, or as Ruskin puts it, how to select the right line for each of many thousands or millions of situations, and how to let writers control the selection criteria. And this set of challenges led us to two primary design goals for the system. First, to augment the skills of human creative writers of widely varied and varying technical proficiency with generative processes. And we can think of this maybe as a continuum of generativity or procedurality, with traditional static text on the left on one side, and procedural or generative or dynamic text on the other side. And one of the most interesting results from Tendar, for me at least, was the degree to which traditional writers began to pick up procedural ways of thinking and working over the course of the project. Something that may be useful for tool makers to think about and recognize. So how do we support movement along this spectrum in Dial? So first off, strings in Dial script are first-class language elements, so no quotation marks are required. The syntax follows common screenwriting conventions. We can use plain text files created in any editor, and generative primitives exist that can be easily integrated organically with the static content. And the intent here is that all writers will feel immediately comfortable using the tools, and that they won't need to switch languages or tools to, say, a code editor or an IDE as they progress along this continuum. And you can see a bit of the dial syntax here, which at its simplest and most static looks much like a standard screenplay at the bottom of the screen. Here are 10 more lines of valid dial script, which is interpreted via an ANTLER 4 grammar. And they include primitives for identifying speakers, for integrating random variation, for referencing writer-defined or game world variables, and for calling out to, in this case, a context-free grammar, which is also written simply in dial script, or to other NLG or even sort of deep learning language models outside of the game. Our second core goal was to enable smart dialogue selection under the control of writers, as both writing and game change organically over time. And by smart here, I simply mean the most contextually relevant fragment of dialogue for a specific game state. And here again, there's a sort of spectrum or continuum of specificity. The idea being that we want to get a minimal game up and running as quickly as possible using generic dialogue, and then allow writers to craft more nuanced and expressive and situation-specific dialogue as the project progresses. And we also want this new dialogue to integrate seamlessly into the game when it's ready, without requiring additional work from programmers, thus giving more control of the dialogue selection process to the writers and decoupling writing from game programming so that each can proceed at its own pace without blocking the other. And the mechanism Dialogic uses to support this sort of spectrum is called Constraint-Based Fuzzy Search, or CFS. And it works with find, which is one of the 8 primitives in dial. And I'll just go through one very simplistic example to give a high-level idea of how it works. So imagine we have a situation where a greeting needs to be chosen based on the current strength property of a player. In a traditional language, we might find a conditional like shown here, which seems fine enough at first. But what happens when later writers want to add further nuance so that the greeting also depends on the player's hunger? Now, programmers need to go back into the game and add more conditionals for when the character is strong and hungry, strong and not hungry, weak and hungry, and weak and not hungry. And for each new property, we consider the number of paths at least doubles, and our conditionals quickly become unmanageable, what's sometimes been called conditional mayhem. So in Dialogic, rather than using conditionals, we tag dialogue fragments or chats with metadata, and this is a bit similar to the expressionist system, which are evaluated at runtime. Instead of changing code when new dialogue is added, the writer simply adds meta tags to that new dialogue. So we have more specific greetings being added, and we simply change our find call as above, indicating that the name of the chat must match the string greeting. You can see the code developing here. Each of the 3 chats shown will match this constraint, but one of the latter 2 will also match the user strength constraint. Therefore, it will score higher and be selected, all things being equal otherwise. As more specific dialogue is added, taking into account more properties, writers simply tag the new chats appropriately. The find call remains the same, and most importantly, no game code needs to change. And in fact, new dialogue can even be added as part of a hot update while the game is running. A bit more specifically, CFS treats dialogue selection as an iterative search over a database of key value pairs consisting of game world properties and the metadata attached to chats by writers. It selects the dialogue that best matches the find query, weighted against how recently the fragment of dialogue may have been used. And all of this can be precisely specified with a variety of operators. Here we see some of the find operators supported, including the bang operator, which controls whether constraints are allowed to be relaxed during a search. And here we have operators for exact and partial matches, for negation, for comparison, for using regular expressions, and even the use of embedded dial script expressions. So I don't have time now to talk through the other features of the language and the runtime today, but they're laid out in some detail in the paper, and it is open source, so all of the code is available online for your reading enjoyment, or feel free to email me with any questions you might have. So thank you. I'll end there, and if there's time, perhaps take a couple of questions.
Thanks, Daniel. So is there any questions there?
Sorry, I have more of a comment than a question, but Daniel's paper was also nominated as one of the best papers, just for...
Oh, thank you. So I see a few in the chat.
Yeah, been asked for the link there.
I will.
Yeah, so asking about how the developers debug the scripts using the workbench. So if you can comment anything about
that. Right, so the workbench has validation and linting built in. So invalid scripts are the line on which the error occurred is highlighted, and then also sort of style elements are caught by the linter. So that's how that works inside the workbench. And yes, someone's already added the dialogic link and the paper link. Thus far, dialogic was originally written in C# for Unity. I'm in the process of just about finished with porting it to JavaScript, so it can run in browser-based games.
Okay,
I was
fantastic.
wondering, question.
Yep.
Wondering if you could comment on the voice actor bottleneck that many systems like this face.
You mean the resource of finding voice actors?
Yeah, or just it seems like a very branchy dialogue like this, system like this couldn't work with the voice actor sort of system that the AAA industry has. Right.
So in both of these experiences, Tendar and Spectre, all the dialogue is textual. So you're sort of chatting with your virtual fish in Tendar, and through interacting through Inspector through a touchscreen. So I haven't considered, I see in any generative system how that can be a problem, but I don't have any particular insight into it beyond that.
Okay, I think we're gonna have to move questions, if you have any, Daniel, over to the Discord just to keep our focus on time. I have a question, but I think I'll move it there. Okay, so next up we have, looking at the use of, or the creation of snow simulation. So if Andreas or George are around, or if we have a video, I'm not sure.
No, we don't have a video. The next one is the blockchain technologies.
Yes, I'm here.
Okay, so if I want to go ahead with the blockchain, then if we need to, we can drop back.
Did you get a link with the video?
Sure thing.
Should I play it from my computer? Then I just play it from my computer. Ella, blockchain technologies and games, a proper match. Welcome to FDG20. Welcome to Virtual Malta. Who are we? My colleagues are Thomas Lembacher from Danube University Krems, Simone Kegelstein from the Austrian Institute of Technology and the University of Vienna. And my name is Alex Pfeiffer. I'm a postdoc fellow at MIT and a PhD candidate at the University of Malta. What we did is expert interviews with 23 experts from the field of gaming and blockchain on the topic of how to use blockchain technologies in the gaming industry. Blockchain in a perfect world would enable trust between different parties. It would ensure transparency while still keep up privacy, because of course you can encrypt messages, and smart contracts would enable automation processes between the different parties involved. Imagine this: Niantic pulls the plug on Pokemon after 4 years. This was a joke that came up yesterday on Facebook. And this really helps you to think about how blockchain can help. So if those Pokemons are stored as a different blockchain tokens in the players' wallets, even if Niantic turns off the game and turns it on again 2 years later, players would still have their own Pokemons secured on blockchain in their wallet and would be able to play again with the Pokemons they already possess, or in other Pokemon. They could be used in other Pokemon games for other purposes. So we come to the first chapter, and this is collectibles. The most famous collectible game on blockchain is CryptoKitties. There was this huge hype in the early 2018. CryptoKitties are based on a unique DNA. Each kitty is unique. And you can breed the kitties, you can trade the kitties, you can sell the kitties. Kitties have been gifted to President Trump and Secretary Clinton, so they're now in the US National Archives. I think it's a nice side joke up on the topic, so to say, from WikiLeaks. And although the big hype is over, CryptoKitties is still there, and they still do updates and new mechanics. So it's really great to look into it. It's based on the Ethereum blockchain. Recommendations from the expert, what they discussed with us. One game is called Tarasca. It's a collectibles game on arts, and it's based on the Ignis child chain of the Other network. And you can sign up for the beta and you can test the game. Another game recommended, it's called Cryptic Legends. It's based on Ethereum again. It's a story-driven hero manager, and each of your hero is represented as a blockchain-based token. And that this could be a really great thing, and it's not just an idea from independent developers. That's something that Panini America proves, I think, we think, because on paniniamerica.net/blockchain HTML, you see their efforts on how to secure trading cards on blockchain technologies. So in-game items and in-game currencies. The idea is to secure in-game items from your game, from your massive multiplayer online role-playing game on blockchain. So an idea would be, regarding the experts, that gray items are just database entries, and when it comes to items with value, you secure it with blockchain technologies. So for green items, the tokens can be reissued easily. Epic items would be like limited edition tokens that cannot be reissued, and legendary items are single tokens or NFT that are unique, that have the unique asset ID, and that cannot be reissued. Another approach is using like the Lightning Network. It's a second layer solution on Bitcoin. For example, here into shooter games, the Bitcoin Bounty Hunter, or the more famous Light Night game, where you shoot another player, and as a reward you receive for Satoshis. Satoshi is the smallest amount of a Bitcoin. So 1 Satoshi is a 100 millionth of a Bitcoin. Another great example is Beyond the Void. You can still download the game on Steam, and the in-game item token Nexium has been traded on cryptocurrency exchanges, which leads to that on one day, one Nexium cost like $40 on the other day $80. And then in the bear market, this declined so much that basically it's no longer traded on the platform. So the game is still there, but no one can buy Nexium, so no one can play the game anymore, besides maybe those players who have Nexium in their account and already have their spaceships. And this showed that you should really separate the share as an investor, the share that is traded on the free market, like the stock exchange shares, with the game tokens that are used in the game. And the experts actually recommended that in this particular case, with game items, the price should be set by the company in a regulated way. And then players, so for example, when you stop playing the game, could sell off via the marketplace their tokens to another player, can sell it back to the company, can use it in another game. For loot boxes, with smart contracts, you can set obviously the chances of the items you receive. And so if there are upcoming laws regarding loot boxes, smart contracts can ensure that you play by the rules. A game that we recommend, it's on the topic of blockchain of Bitcoin. It's called Bitcoin Billionaire, and it's a clicker game, and you earn virtual Bitcoins. To say it's just a game at the beginning while tapping on your screen, but it's fun and you really learn a lot about the industry in a fun way. Gamification, same as with the in-game items. So you secure your points, your badges, your achievements on blockchain. You can set up smart contracts. You can easily set up a marketplace, connect with external partners, so you can create a full working ecosystem. And this is what we did in the project Hot City. With that, we won the blockchain award in Austria in the category Research and Development. So it's just search for Hot City gamification on Google and you find more about that. Game-based learning and assessment, that's my MIT project. You play a serious game for assessment, you get the grade. Immediately, one token is being sent to the player, who is the learner. Another token is being sent to the teacher, and the token represents your grade. And that then you generate a shared key, you can share it with third parties. For example, if you apply for a job. Esports, it's a really big thing, betting on esports results. So the Austrian company HeroCoin is doing that. Nowadays, it's done using Ethereum, one of the leading cryptocurrencies, but they also had their own approach. They had at first their own token, and basically the trading volume of their own token nowadays is just like 500 euros. This leads to the next chapter, and this is speculation and the game on Twitter. So Twitter still has a high influence on blockchain and on the speculation game itself. So one tweet could really impact what's happening with the coins, especially with low trading volume. You can set up full gaming ecosystems on blockchain. That's something we did with Danube University Krems, and the sports game that has been produced in Austria. So those who help to maintain the game actually receive tokens and can sell it. Mining itself can be perceived as a game, and of course, gaming could be a mining mechanic for future efforts. And the last chapter is fraud, so please be super careful because newbies get wrecked, and Crypto Quitter gives the grades. So thank you very much, and have a great day.
Thank you. So are there any questions? Nothing? Okay. I can't see in the room Andreas or George. I don't know whether they're about or they're lost in the midst of Zoom. So perhaps if we can move on to the next paper, which is about the explorative design process for game map generation based on satellite images and playability factors. So again, is there somebody there to present that?
Yes,
Brilliant.
I have a presentation, so I'm going to share my screen.
Okay, great.
Can everyone see my presentation?
Yep, it's great.
All right. Hi everyone. We have developed a tool for procedural terrain generation and, more importantly, evaluating the playability of the generated terrains. So this is our team. My name is Georgi, and I'm a recent master's graduate from Aalborg University, Copenhagen. And I'm going to present from the name of our team. So first, I would like to address your attention to procedural generation and more specifically how it ties with terrain generation in computer games. Procedural terrain generation or map generation has recently become quite popular as it has quite few advantages. For example, it can add a lot of replayability to the video game maps. It can, with the proper fine tuning, it can also add a lot of nice variation and results that have not been expected, even nice results that have not been expected even from the developers. So it is essentially a way of automating the process of manual video game map development. However, in order to get satisfying results, there's a lot of fine-tuning involved in the algorithms used for procedural map generation. And oftentimes, it's a matter of a balance between producing a lot of uniformity versus producing a lot of variability in the results. And this could be a very cumbersome process for the developers. Therefore, we propose a tool for evaluation of the produced procedural terrains in terms of their traversability and therefore playability for video games. I'm going to introduce you the most important key elements that we use as a background for the development of our tool. First, we looked at noise functions as they're currently the most widely used method for procedural terrain generation, mostly because of their ease of implementation and the fact that they have been around for quite some time and they have been explored very thoroughly. So there's several problems with them. As I mentioned earlier, it is often a fight between producing a lot of uniformity in the generated maps versus producing a lot of nice variability, and neither of them is good or bad. It's all dependent on the application. However, for example, oftentimes those methods are quite limited. There are several ways of improving them. However, we have decided to look at a more modern way of generating procedural terrains that comes from the field of machine learning, more specifically using generative adversarial neural networks, GANs for short, which can be used in a variety of ways. The way we have used them is in order to feed them real world images and then based on them generate similar height map terrains. Finally, the most important perhaps part of our project is the way we evaluate the produced terrains, and that is through pathfinding. The way our tool works is on two main sort of stages. The first stage is the producement of the procedural terrains, and then the second stage is the evaluation. So if you can follow from the upper left corner to the right, we first take a very high resolution Earth texture map that comes from the NASA project Visible Earth. This was inspired from another paper that also aims to produce procedural terrains through generative neural networks. And we use the same image. Then we extract the height map of that very high resolution image, and we apply a kernel window with a much smaller size, more specifically 512 by 512. We use this window to splice the high resolution image, and then we take random samples out of that image. We use those samples in order to feed the neural network as initial training data. On each epoch, the neural network produces 16 pairs of height maps and texture maps based on the data that we've fed it. We have taken 10 of those, and we have used the height map data in order to produce playable terrains, as you can see here in the middle to the left. The way the playable terrains are produced are basically, we look at the height map data, and for example, if the value is very low, then we consider this the bottom of the sea, or if the value is very high, then it's probably the peak of a mountain. Based on that, it is scoured, and then the mesh is generated, or rather the other way around. Then we move on to the second part of the architecture of our tool, which is the evaluation of the produced terrains. The way we do that is through a pathfinding algorithm. The reason why this works so well is because one of the big issues in this very convenient process of automating terrain generation with procedural algorithms is that once a very large terrains are created, it is very hard to evaluate manually whether or not they would be actually traversable by the player and therefore playable at all. Therefore, what we do is that we, using several metrics based on the height map data, we apply a node grid onto the produced terrains. Using ray tracing, we determine, based on the height of each node, whether or not it is walkable. Here you can see an example where the red part of the map is the non-walkable terrain, whereas the white one are the walkable nodes. Then we use pathfinding algorithm. The reason why we choose A star is because it is very well explored, very well optimized, and it suits the needs of our project just well, as one of probably the most famous pathfinding algorithms. The A star algorithm will generate 20 separate paths for each of the 10 produced terrains. The reason for that is in order to have a higher number, which allows for avoiding different biases, which we're going to discuss in a minute. Here you can see an example of path in black that is generated between a starting and ending point. The way the starting and ending point are chosen is completely random. The only criteria is that they have to be on a walkable terrain, and there is a minimum length to the generated path, but not a maximum. What we do at the end in order to evaluate the terrain is that we compare the generated path to the Euclidean distance between the starting and end point that the algorithm has used. This proves to be a great way for assessing the entropy of the generated terrain and how traversable it is due to the high versatility, due to the high variability of the maps that the GANs has generated based on our initial training data, which can obviously vary if you change the images that you initially feed the neural network. Moving on, this is more of a close-up example of how the produced texture height map pairs of the GANs look like. There are some example of results for the application of the tool. Here on the x-axis of the graph, you can see each of the 10 maps that we have generated. And on the y-axis, you can see the extra length that has been extracted between the Euclidean distance between the 2 points of each path and the actual generated path, which is almost always a positive number. Looking at this graph, the first thing that gives impression is that there's quite a lot of variability between the 10 maps, which would suggest where we have a very high entropy for some and almost none for others. And we'll see what that means in a second. Here you can see 2 very important numbers. When we boil down this graph data, we can get this percentage, which is the average extra length for all 10 maps and all the paths generated for each of them. We presented it in percents just for ease of use. What you can see is that the number is not quite high, which would suggest that the entropy of our produced batch from the high resolution image of Earth is not very high, which would suggest relatively easy to walk terrains, and so they would be well applicable for games where you want your player to be able to explore everywhere. However, when you look at the second number, that is the total number of separated points for all the 200 paths that have been generated for all the 10 procedural terrains. Now, 86 out of 200 is quite a high number, and those, just to clarify, are the points, the start and ending points that have been, for example, generated on 2 separate islands, separated by water, or a very high mountain in between, and therefore the algorithm cannot generate a walkable path, which contradicts the first number. What would this suggest is that, in fact, even though we observe low entropy, we actually have a lot of walkable islands, which are, however, separated in some way. So we can already get a quite decent picture of the terrains that we've managed to generate with the neural network. Finally, the tool presents some biases still. Here I'm going to address several of them. These are some of the most interesting images that I would like to show you. On the first one, you can see the walkable and non-walkable nodes for a certain generated map. You can see that there is no generated path. The reason for that is because the starting and ending point have been generated on 2 separate islands. Even though you can see on the bottom right corner, there's a quite, or rather on the right of the image, there's a quite a big island that is that gives an opportunity for exploration. But even if that's the case, just by chance, the algorithm has produced non-walkable paths. And this can be confirmed further with the second image, which you can see again has quite a big island, which, however, is pinched by a lot of non-walkable nodes. Most likely those are very high peaks, which have to be walked around, which you would assume means higher entropy and lowers the traversability of the terrain. However, in this specific instance, the algorithm has produced a quite straight walkable path, which compared to the Euclidean distance between the points would give us very low entropy. And this is why, as I mentioned earlier, we produce 20 paths for 20 different paths for each terrain in order to avoid such specific biases, which are produced by the imperfections in the generation method. Finally, the tool has shown a lot of potential in terms of evaluating different procedurally generated terrains. One of the most important sort of findings, and also path for future developments that can be extracted from this process, was that the way we have formed our architecture, the produced procedural maps can be refed into the neural network if they have been desirable for the developer, and then by fine-tuning the neural network, more better results can be produced each time while eventually reaching a perfect result, which essentially automates the process of evaluating automatically produced procedural terrains. There's also several different things that can be tweaked, the difference in training time, and most importantly, the difference in the initial image data that has been fed to the neural network can greatly vary the properties of the produced terrains, and therefore gives the tool even greater versatility. Yeah, I think this is all, and I'll be happy to answer any questions that you have for us.
Okay, so I think that we're going to be running really quite close to time if there are any questions, but I'm sure that we can move this over to Discord. So yeah, if there's anything that's really quick, we possibly can do that, but to be honest, perhaps we can move it over to Discord and have that conversation there, unless it is quick. Yeah, I think we'll move it over to Discord so that we can have the keynote. But thank you all that were involved, and I'll see you in a while.
Thank you.